Hello everyone and welcome to a new Sega Mega Drive and Genesis game dev tutorial. The previous lesson was a big one at over an hour long where we set up the level collision code for an overhead game. Given the popularity of Zelda: A Link to the Past, it's surprising that there weren't more of these overhead adventure games in the 16-bit era, so hopefully some of you will use this code as a foundation to create your own new games. By far the most popular type of game during that era was of course the classic side-scrolling platform game, and it's that kind of game that we're going to be creating the level collision for in this lesson. Thankfully we can use our collision code from the overhead game as a foundation. We can build on that, just make a few changes and we'll be done. Let's begin by taking a look at the tile set that we'll be using for this lesson. I'm not sure if you recognise which game it's from. Now first of all we have these ground tiles which of course the character is going to walk on, and then we're going to have these platform tiles that we're going to practice our jumping with. So these are going to be purely solid platform tiles, you're not going to be able to walk through them or jump up through or down them. And then we have this type of tile which is very common in these type of games where it's kind of like a semi-solid platform tile where you can move left and right through it, and you can move up through it, but on the way down is going to catch you. And then of course we have the slopes as well. Now when it comes to the slopes and the semi-solid platform tiles, we'll cover those in another lesson, but today we're going to focus on the basics of the solid tiles, the solid platform tiles and the ground, and we're going to input gravity and also jumping for our character too. You can see here in 16 tile I've already created our level map as well as our collision matrix, our collision array, so I won't go through it here because I've already covered 16 tile in previous lessons, so check those out if you can't remember how this is done. But for now I'm going to go ahead and export this map and we're going to use it in our project. Okay, so continuing on from the code we wrote for the overhead level collision, first of all we're going to delete the background we created for that one. We're going to keep the Senti sprite for now, although we will replace that later on in the lesson, and we're going to put the new map that we created using 16 tile into our res folder. Since we're now using a different file for our background, we're going to have to change the name in resources.res, so highlight the old one, do Ctrl-Shift-L, and then we can change all of these at the same time. Don't forget to save the changes in resources.res and then we can move on to main.c. The new map we're using is a much bigger one than the one we used in the for Crusader of Senti, so we're going to change the map width and map height. Remember these are all in terms of pixels and not tiles, so however long they are in pixels and however tall, just write that here for your map. We're also going to need to change the value of the length of the collision array. So remember this is the width of the map in terms of 16 by 16 tiles. So take the width in terms of pixels and divide it by 16 and we get 72. Now we're going to have to change the collision array itself. So remember in 16 tile it will produce the collision array for us, so we can simply copy and paste. You can see that this is a much bigger map than the one I did last time, so I'm glad that we now have 16 tiles so I don't have to write a huge map out like this manually piece by piece. So all you're going to do is you're going to copy the information inside the brackets and we're going to paste that inside the brackets in our main.c. Be careful that you haven't accidentally pasted over or deleted any of the brackets or the semicolons. And next we're going to change the number in the square bracket. So remember this is the size of the array, is the total number of pieces of data in the array. So in our new array it's much bigger, it's 2232 ones and zeros. So that's all looking good. Before we save and compile, let's get rid of this debug info. Remember in the last lesson we put some debug info on the screen, but we're not going to need it now. So let's delete those 3 pieces of lines of code, save and compile, and now let's take a look at our ROM. As I said before, this is a much bigger map than last time, so let's take a walk. Just make sure you collide with the floor and the different sections of the map just to make sure that the collision is working correctly. If you get any bugs at this stage, then it's probably when you was doing the changing the length of the array and so on, you probably made a mistake there, so go back and check. But you can see the collisions are working okay. Remember for Senti sprite, the collision box is the little green box, so it looks like his head's moving through parts of the scenery at some points, but that's totally normal, it's just the way we set up the collision box. Once you're satisfied that that's all working correctly, we can now move on and turn this from an overhead collision system into a regular 2D collision system with gravity and jumping. So let's go ahead and start that now. Since we're moving to a side-scrolling platformer, we're not going to need the up and down movement that we had before in our overhead code. So the first step is going to be to get rid of that. Let's scroll down and find the booleans for player move up and player move down and delete those because we're not going to need those anymore, and then go to the handle input function and delete the up and down movement from that too. Of course, we're still going to need to move left and right, so we're going to leave all the left and right movement where it is. We still have lots of code to do with moving up and down in our collision function, of course. So next up, we're going to make some changes there. The first of which is going to be to take the if player move up statement and all the code within it and just comment it out. So the reason for not deleting it right now is because we're going to be using some of this code later on. So for now, just comment it out by pressing Ctrl//. For the move down code, we're going to have to do something slightly different. So we're going to delete the else if line and that opening bracket, and also go down to the bottom and close and delete the closing bracket too. Because obviously now, when previously in an overhead game, you only need to check the bottom collision if the player moves down on the D-pad, but because it's a side-scrolling platformer now, gravity is going to be acting on the player every single frame, so we need to check this every single frame. And of course we need that code to stop the player from falling through the floor. And as for the code to do with moving left or moving right, we don't need to make any changes, so just leave that exactly how it is. Back at the top of main.c, we're going to need to create another two variables. The first one is going to be gravity, so make it a fixed 32 number, and for now make it equal to 0.8. We're going to change this value a bit to experiment a bit later on in the lesson, but for now just do it as 0.8. And the next one we're going to create is another fixed 32, and it's going to be the player y velocity, so the velocity on the y-axis, and we're going to make this equal to 0 for now. Creating this new velocity variable does create a little bit of a problem though, because remember previously we already have a player underscore vel variable, which was for the velocity for going up, down, left or right. It just moved at 1.5, there was no acceleration, and of course because this could be a bit confusing in our code, we could get it mixed up, so I'm just going to rename this to player underscore x underscore vel just so we can differentiate it. And as usual, I'm using Ctrl/Shift/L to make sure that this changes everywhere in our code. So if we just scroll down and check on the player move left and player move right, you can see that this has been changed to player underscore x underscore vel already. However, that has also had the effect of changing the code what used to be in our move down part of the function. So let's just change that to player underscore y underscore vel. And just before that, we're going to take the player y velocity and we're going to add gravity to it. And that's going to have the effect of gravity is going to increase, the velocity is going to increase every turn. So it's going to be 0.8, then 1.6, then 2.4, then 3.2 and so on. So just as in real life, the gravity is going to accelerate the player downwards. And remember, the top of the level begins at 0 and then it increases. So if we add any value, it's going to have the effect of dragging the character downwards. One more thing we need to do before we save and compile is to reset the player velocity, the y velocity, when they hit the ground, because otherwise the gravity will continue to be added to that and it will just increase infinitely. So in our code where the bottom of the player's feet hit some kind of solid tile when they hit the ground or hit a platform, we're going to reset the player y velocity to 0. Later on in the video, I will comment this piece of code out just so you can see the effect that happens when we don't have it in place, but for now set it to 0, then we're going to save and compile and take a look at the ROM. Actually, before we do so, let me first scroll to the top of our main.c and change the beginning coordinates of the player, because we have a much bigger map here. So let me move the player down a bit and change player y, the starting position, to 150, and then let's shift the player over to the right a bit more, so maybe 250 or actually maybe 300. So if we now save and compile, we should see where it goes. Well, that went a bit quickly. I'm sure you saw the player drop from the top, and of course then we can move down the stairs and we can move left and right as far as it takes for us to hit some kind of collision tile, and then it stops us, so the code's working fine. But of course the problem is once we get to the bottom here, we have no way of moving back up again. Now of course, the same as on Earth where we live, if you want to defy gravity, you want to move up, you're going to have to jump. So that's what we're going to do next. As is often the case, the first step in this process is to create a new variable. So we're going to create a variable called jumping velocity to see how high the player jumps when we press the jump button. As with gravity, we're going to experiment a bit with this value, but for now just put it as 12. I'm now going to insert our button controls. Now, if you can't remember how to do this, then check out the lesson from a while back, how to do button controls, but I'll just go through it quickly here. So we set up our function prototype, then within main we set this joy set handler, and then finally we go to the very bottom, and this is where we're actually going to create our function to handle the button controls. Of course, we're going to need an if statement, and so if you press a certain button then something happens. Now when it comes to jump buttons, I prefer the C button, but I know lots of people prefer the B button. SGDK does support X, Y and Z, the 6 button controller, so feel free to put it there if you want. And remember, we always just do this changed and state and then the button you want to program for. And again, if you want further explanation, then check out the lesson I did on button controls earlier. Within this if statement is where we want to actually add the jumping velocity to our regular Y velocity, because if the player hits a C button, then we're going to subtract the jumping velocity, because of course if you want any upward motion, then we need to use a negative number. Checking out the ROM now, you can see that we're no longer stuck in this bottom left hand side. We were able to jump back up these little steps, and we can also have some fun with the platforms, so it's really starting to feel like a game now. We can jump back and forth. By changing the values of the jump velocity and also the gravity, of course you can change the arc of the jump too. However, there's still a little bug in our code, and I'm going to demonstrate it for you now. So if I keep pressing the C button quite rapidly, you can see it keeps subtracting the 12 from the player Y velocity, and of course gravity is only adding 0 point each turn, so it's very easy to shoot up in the sky like this. Although I did call it a bug earlier, it's not necessarily a bug. It depends on how you want your game to control. So lots of games, for example, have like a double jump or a triple jump, so in those circumstances you're going to want to allow the player to hit the jump button once or twice again when they're in the air, but you probably want to limit how many times they can do this. And of course for some games, for example when you're underwater, the jump button will dictate your buoyancy, so you're constantly sinking down and you keep pressing C to rise up under the water. I think Mario does this. However, for our example here, let's go into our code and let's make it so you can only jump once until you land on the ground again, and only then can you jump up again. So in order to do this, first of all we're going to create a boolean value. So we're going to create one called jumping, and we're going to set it to false. Let's now head down to the bottom of main.c where we have our button controls, and within that if statement we're going to make it so that when the jump button is pressed, it changes jumping to true. And then within the if statement itself, within those brackets, we're going to add another condition. So we use to and to do a logical condition. So we want to make sure that the player is pressing C and that jumping is equals false, and only then will it actually it will subtract the jumping velocity and allow us to jump up. Since when we do press C, jumping change to true, it means that we can't press C again until we change jumping back to false once more. The point at which we want to change jumping back to false is of course where we hit the ground. So when we go to the code for the bottom collision of our sprite, we'll then change the jumping to false at that point. If we now save and compile and we load up the ROM, you can see that we can jump up and down, but we can't do the double, triple, quadruple jump anymore. We can just jump around as normal, and only when we hit the floor are we allowed to press the jump button and jump up again. With that being done, it's already feeling a lot better, so it's feeling more like a normal game again. So again, let's practice by jumping up these platforms here and seeing that's working. But if I go below a platform now and try and jump up, you can see that there's still something else we need to fix, and that's because if you recall, we took the top collision of the player of the collision box and we commented it all out, and I said that we're going to start to use some of that code. We're going to start to reintegrate it back into our collision code, so let's go ahead and do that now. I'm just going to go to the code that we already have in place to deal with the bottom collision. I'm just going to rearrange it a bit so it's a bit more clear, so I'm going to cut that and paste it there. Said that it doesn't make a difference to how the code works, it just makes it a bit more obvious what's going on. So the 6 lines at the top there, you can see that we have the collision boxes for the bottom, the left and the right hand side. So what we need to do now, we need that for the top of it as well, the top side of our collision box. So what I'm going to do is I'm going to go to our commented out code for the top, and I'm going to take the relevant parts of it and I'm going to paste it into there. Next, I'm going to take the code that calculates which kind of collision tile the top left and the top right of our collision boxes fall into, and again I'm going to copy that and I'm going to paste it below. With all the calculations now in place, we can again go up to the top and we can copy the if statement from the top collision that we had before, and we can paste it just below where we do the bottom collision, and we can uncomment that out, and I think we can change it to an else if, because normally it's either going to be hitting the bottom or the top, so I don't think we need two if statements. We can have an if and else if, and that will be done. So now we'll have both the bottom collision first. It checks if there's a collision at the bottom, and then if not, then it checks if there's a collision at the top. So this should be enough, as simple as it is, just to stop it so that the head now collides with whatever tile is above it and it doesn't go through the tile anymore. The only way to know if this has worked or not is to check it out, so let's load up the ROM and have a look. You can see here that the top collision is now working okay. Remember, it's the green box we're looking at here, and the player's being stopped from jumping up through the tile, so that's working fine. One thing you may have noticed was that when the player jumps up, they almost seem to linger at the top before they start to fall back down again. This is actually very normal when you think about how we've got our code. We have when they press the jump button, it's been given an upward velocity of 12, and then each frame the gravity reduces that by 0.8. So it starts off at 12, then 11.2, then 10.4, then 9.6, and so on until it reaches 0. And only when it reaches 0 will the player start to fall back down again. Until then, the player character's constantly being blocked from moving up by this tile, by our collision code. This isn't a bug per se, it all depends on how you want to design your game controls. As many of you know, I'm currently creating two games for the Mega Drive. One's GG Shinobi and one is the Castlevania Symphony of the Night. Now both of these games have a different way of approaching this problem. For both GG Shinobi as well as Revenge of Shinobi, which is what you're seeing on your screen right now, the jumping when you hit your head on something above you, the mechanics is pretty much as we have it in our code at the moment. So you hit your head, but the upward velocity doesn't get cut straight away. It's allowed to play out until it goes to the 0. Then once it gets to 0, it starts, obviously gravity starts to put it back down again. And as you can see here, it's actually essential from a game design point of view by how the levels are designed that this is the case, because especially in this section here, if that wasn't the case, then you would obviously fall onto these spikes. So the people who made the game, they've taken this into account. In Symphony of the Night, on the other hand, you can see that when Alucard hits his head, he pretty much falls right back down again. There's no delay as the upward velocity plays out. So there's no right or wrong answer here, it's just however you want your game to play and however you want to design your levels. If you wish your game to have a Symphony of the Night style head bump rather than the Shinobi style, the solution is very easy. Just as we did with when the player lands on the ground with their feet, when they hit their head on the top, all we've got to do is reset the player Y velocity and reset it to 0. That means as soon as they hit the top, the velocity will be 0 and then gravity will start to take its course and drag the player down again. And you can see the change reflected in our ROM here, as when the player hits his head, he now falls down straight away. I said before that we would experiment a bit with the code, so let's do that now. And what I want to do now is to comment out this resetting the player Y velocity to 0 when the player lands on the floor. And I'm also going to change the gravity as well. If we save, compile and load up the ROM, you'll see that while we can stay on this platform for a while, after a couple of seconds it's going to fall through. And that's because obviously the tile is only 16 pixels in height, and the player velocity, the Y velocity, keeps getting added to until the point where it's more than 16, at which point the per frame checking, it checks past the 16 by 16 tile and it's just going to fall through. So you have to be very careful to make sure that the player if you're using 16 by 16 collision tiles, to make sure that the player velocity in any direction never goes over 16, because if it does go over 16 at any point, then there's always a chance that it's going to pass through any single tile wall or single tile floor. You can see that here where I've changed gravity to 2.0, so if I jump up on this platform, by the time the character reaches the bottom of the platform, the downward velocity is going to be greater than 16, and so the player is going to fall through that platform without getting stopped. I can also show this happening in a different direction. For example, if we increase the jumping velocity to a really high number, we can do it so that the player, when they jump up, they can jump through a platform, because so long as the upward velocity is more than 16 at the point where the top of the character collision box goes to the platform, then they'll go straight through. So when we jump, the velocity is at 35, but of course that's been slowed down by gravity. But for the platform on the left here, it hasn't been slowed down enough to be under 16, so the player still goes through, whereas the one on the right here, the gravity has already slowed the upward velocity down enough so that it's less than 16, so the player can hit their head. Thankfully, it's very easy to prevent this bug from happening. So first I'm going to reduce gravity to 0.8 again, and we just have to make sure that the jumping velocity is lower than 16. That will guarantee that it's not going to go through the top of any tile. And as for the downward gravity one, just as in real life, we can set a terminal velocity, so we can do a maximum downward velocity that the player can go in. As long as this is less than 16, then we won't have any chances of the player falling through any platforms either. After defining how much we want the terminal velocity to be, we simply add an if statement in the player collision code just after where we add the gravity to the player Y velocity, and we say if the player Y velocity, if that ever gets greater than the terminal velocity, then just make the player Y velocity equal to the terminal velocity. So that will guarantee that it never goes above the terminal velocity, which we set at 4 in this case. If we then load up the ROM and go to the very top and jump off, you can see that it's being capped at 4 per frame. The downward motion, it looks very floaty, so this is probably lower. The terminal velocity here of 4 is lower than you probably want it, but as I said, it all depends on your game. I think for example, the Super Mario World, where the Mario has a cape, I think, something like that, you could do a very low terminal velocity, but in most cases, you're probably going to want a higher number, maybe 8 or 9 or 10, 11, 12. So feel free to experiment with all these values with the gravity, the jumping speed and so on, and just take care that the velocity never goes more than 16, never goes above 16. And of course, in our code here, the left and right directions, they only move at 1.5 per frame anyway, so that's not going to be a problem. But if you had like a Sonic-like game with momentum-based physics, then you'd have to take care that the player doesn't overshoot 16 pixels per frame in the left and right directions too. There are still a couple more things that we need to go through before we've got complete 2D collision for a 2D platform game, but I can see that the tutorial is already over 20 minutes, and I'm trying to keep these lessons to these videos to a reasonable length. I think that's less tiring both for me as a creator as well as for you guys as students. So I'm going to split this one up, and in the next lesson we'll cover how to do the collision when you're using a large sprite, because once you use quite large sprites instead of the small centi sprite we're doing here, things do become a bit more complicated, so we have to make some changes. And then secondly, there's a very small bug in our jumping code where you can actually still jump mid-air under certain circumstances. I'm not sure if you can guess from the code itself what those circumstances are, but anyway, we're going to fix that bug, and we're going to put a much larger sprite into our game here, and then you'll see the changes we have to make to that. As usual now, I will post the source code for this tutorial on my Patreon, so big thanks for all the supporters over there. Okay, so I think that just about wraps things up for this video. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
farewell.